Madhulika Kumar. She has completed her Master of Architecture in Architectural Association, London, UK. She then went on to work at Shanmugam Associates and integrated design on projects ranging from residences to regional planning, sustainable master planning, water calculation, etc. She was also known for her master thesis, which was selected for public display at AA, which was also selected for summer exhibition and shortlisted to publish at a national conference in UK.
Welcome to UGC lecture series. Today's topic is Energy Efficient Architecture, Unit 1, Passive Design, Lecture 1, AR 6002. Presentation outline. Presentation is divided into three main parts. First is introduction, and then we move on to passive design, and then what is passive cooling and heating. So, passive design. Passive design is a design that takes advantage of the climate to maintain comfortable temperature range in the home. Passive design reduces or eliminates the need of auxiliary heating or cooling. So, before starting any type of design, we must understand the climate in which the project is going to take place and how the climate is going to contribute to the built environment, because human can adapt and be comfortable only within certain range of temperature depending on their location and their cultural experiences. So, to maintain the same band and to maintain the thermal comfort, we must be aware of the climate of the locality and take advantage of the different aspects of climate to reduce the external use of heating or cooling, which will in turn benefit us by reducing our energy bills. Importance of passive design. The importance of passive design cannot be overstated. Paying attention to the principles of good passive design suitable for your climate effectively locks in thermal comfort, low heating or cooling bills, and reduced green gas emissions for the lifespan of your home. When you consider the principles of good passive design according to your climate and traditional homes in the locality, it helps and makes sure the thermal comfort within the built environment can be locked in, and it can be used by the users without using any type of external devices to keep the thermal comfort inside, and which in turn benefits us by reducing our energy bills and also by saving us from climate change. Passive design utilizes natural source of heating and cooling such as the sun and cooling breezes. It is achieved by appropriately orienting your building on its site and carefully designing the building envelope, roof, walls, windows and floor of a home. Well designed building envelope minimizes unwanted heat gain or loss. So, when you start a design, you must know about the local climate, temperature bands, and how many people are going to use the space and what type of radiation, different devices which is going into the space is going to create. And with all this information, theoretical information that we will have in hand, we can be able to place each and every detail correctly, which will reduce the heat loss or heat gain. So, for example, if you are in a region which experiences longer winters, you want to trap in natural solar radiation inside. So, because of which you must be orienting your buildings facing towards the south and the west, which will benefit by the solar radiation which is falling. But on contrary to it, if you are in a region like a tropical climate, you want your building to be oriented, longer facades to be facing north and the south, which will reduce the solar radiation which is coming in, and shorter dimensions should be facing east and the west. So, this type of small orientation of the building, and all from that level to usage location of windows, roofs, wall types, wall thickness, everything should be understood by understanding about passive design. So, this is how the building will be oriented, and then this can reduce heat gain or heat loss. And importance of passive design: maintaining the right interior temperature, humidity and air quality often accounts to 30% or more of building's energy use, but you can do this passively without demanding purchased energy at all. So, to maintain a certain type of temperature, we are either using air conditioning buildings or room heaters, which is accounting almost to 30% of energy use within the building. So when you are rightly orienting your buildings and making use of all the passive design principles which will be followed in the subject, we can be able to reduce the usage of external or completely ignore it. Designing passively means working with external weather condition instead of fighting against them. So this is not just finding flaws in your climate, but taking advantage of the climate that wherever you are located in. So how to achieve it? The most economical time to achieve good passive design in a home is when initially designing and building it. However, substantial renovation to an existing home also offers a cost effective opportunities to upgrade thermal comfort. Even small upgrades can deliver significant improvements. So it's better to make your building completely passive design from when you are starting your schematic plan itself, but also for old buildings or buildings which has been already built without keeping in mind of passive design, refurbishment can also be made to improve the quality of air, thermal comfort and humidity levels within the built environment. So even a small change in your decisions and the principles that you are using can affect built environment extensively and reduce your energy demands. Say for example, if you are already built, if there is a house which is already been built like 30-40 years back and you want to refurbish it to help and reduce your energy bills, say it's located in a cooler area, so there will be a lot of cold air which is coming through the construction gaps in the window, between the window and the wall, window frame and the wall, or the door frame and the wall. So there will be a certain air leakage which is letting in lot of cold air to pass through the building, and which in turn increases the efficiency of the room heater and it increases your energy bill. So to reduce that, so you can go for sealing your air leakage. So this is one example for refurbishment. For best results, passive home need active users, people with a basic understanding of how the home works with the daily and seasonal climate, such as when to open or close window, on how operating, adjusting, shading. So it's right. So when it is going to be, even though the architects are smart enough to create sustainable homes or efficient and intelligent buildings, end users must be the one who is going to use the space. So there is no point in creating all these principles in a space which is not being used at all. So it needs active users, and you must educate your clients to when to open the window and when to close the window. So how efficiently a window can be used. Say for an example, if you are located in a tropical climate and there is lot of radiation on the west facade and you are keeping different horizontal and vertical louver system for shading, and the client doesn't even know how to operate it, there is no point in keeping such intelligent systems, which again lets in solar radiation inside the building, which makes the user to switch on the air conditioning to achieve the thermal comfort. So the main aspect is you have to educate your clients to understand how the passive design principle works. A number of different and interrelated strategies contribute to good passive design. Passive design strategy vary with climate, as explained in more detail in Design for Climate. The best mix of passive design strategy also varies depending on particular attributes to your site. So we will follow some of the points which will be explained under the topic Design for Climate, in which we will cover the principles of passive design. Good passive design is critical to achieving a lifetime of thermal comfort, low energy bill, low greenhouse gas emission. So it is not only going to benefit you on an individual, but it's also going to impact on the environment and the biodiversity condition. It's going to help them grow without reducing its effects. So Design for Climate. Good passive design ensures that the occupant remain thermally comfortable with minimum auxiliary heating and cooling in the climate where they are built. Each of 6 main climate zones in India has its own climatic characteristics that determine the most appropriate design objective and design responses. So, when you are designing a building for passive design and with the principles of passive design, it cannot be replicated from one location to another location, which is completely different region and different climatic conditions. So, each and every design that you make with the use of this type of principles will be very unique, and it will be adaptable, and it can be used only to that particular site, because it is using the surrounding benefits and the climate and the weather microclimate aspects of the site. Identifying your own climate zone and gaining an understanding of principles of thermal comfort helps you make informed design choices for your home. Again, India has been divided into 6 main climatic zones, each of which has different passive design principles. So, wherever you are designing, you need to understand that particular climate and what type of design principle has to be used, and which can be even modified according to certain site conditions, and which will be beneficial on a large scale. So, these are different climatic zones. The top, as you see, it's cold, and then the middle strip is mostly composite, and the areas such as Rajasthan and Gujarat experience usually hot and dry, and this light green is monsoonal climate, and here down south is usually warm and humid because we fall in between the band of tropics. Orientation refers to the way you place your home on its site to take advantage of climatic features such as sun and cooling breeze. For example, in all but tropical climate, living area would ideally face north and or as close to north as possible, allowing maximum exposure to the sun and easy shading of walls and windows in summer. So, as we said before, orientation becomes a main or basic aspect of passive design, in which you need to place your building according to your specific climatic zone to get beneficial of out of the climate. So, if you are in a colder region, your building longer facade must be facing towards the west or the south, and when you are on a climate like tropics, your longer facade must be facing towards north. So, it reduces the solar radiation which is coming inside the building, which eventually reduces the air conditioning usage. Good orientation reduces the need of auxiliary heating and cooling and improves solar access to panels for solar voltaic cell and hot water. Your home is thus more comfortable to live in and cheaper to run. So, when you are orienting your building properly, you will also understand about when you are using PV cells to trap solar radiation to get benefited out of for electricity, or if you are using just for hot water, solar hot water systems, you have to orient even them according to the sun path diagram of your location. So, it will be more benefited. For example, if you are in a tropical region, your solar system or a photovoltaic cell must be facing towards the west, because solar radiation is very harsh when it is setting. So, there will be lot of heat and light which is being trapped inside the cells, which will in turn be used as a renewable energy to create electricity. It takes account of summer and winter variation in the sun path as well as direction of and types of wind. So, orientation is not just about the radiation, it is also about the wind pattern. So, when you are making design decisions, you also should refer to windrows patterns, in which you will be informed the prevailing wind directions and towards which you should or should not orient your building. The same, if you are in a colder region, you would not appreciate a colder gush of wind coming to you, but when you are in a tropical region, wind breeze is much appreciated or much expected. So, you have to orient according to the prevailing wind direction, which you can be informed by windrows pattern of your location. How sun path is moving on different dates. So, June 21st is summer solstice, which is longer summer day, and December 21st is winter solstice, which is shorter summer day, and sun path is completely different. So, you have to make a design decision according to your climate wherever you are located. If you are in a colder climate, you have to make sure your colder months are most benefited by passive solar design, but when you are in a hotter climate, you have to orient your building in such a way it is benefited by mutual shading and your building is not exposed or inviting more of solar radiation inside. And this is example of windrows pattern. So, as you see for this building, it is an example, and this side is more prevailing winds. Even though there is wind on all the direction, the most wind direction is towards the east and northeast actually. So, this the windows are oriented according to this direction to invite the cool breeze inside. Shading. Shading of your house and outdoor space reduce summer temperature, improves comfort and saves energy. Direct sun can generate the same heat as a single bar radiator over each square meter of a surface. Effective shading, which can include eaves, windows, awnings, shutters, pergola and planting, can block up to 90% of the heat. So, when you are in a harsher climate with a lot of solar radiation, it's ideal to have huge windows to invite wind, but whereas when you are having huge windows, you are also inviting harsh solar radiation. So, for that you must eliminate the direct solar radiation by using different type of shading systems according to your climate, and you can benefit only by the prevailing wind directions according to the specific location. Shading of glass to reduce unwanted heat gain is critical, as unprotected glass is often the greatest source of heat gain in a house. However, poorly designed fixed shading can block winter sun. So, again it is about seasonal and climatic variation which has to be considered from schematic design development. So, making anything fixed or which cannot be operated is actually a bad kind of design, because it's actually letting in sun, but you cannot you cannot have the ventilation out of it. So, it is just a glass which is just inviting sun inside. So, you must make adaptive opportunities for the user to use and change their environment according to the changing needs and changing climatic conditions around them. By calculating sun angles for your location and considering climate and house orientation, you can use shading to maximize thermal comfort. If it is located in a harsh sun climate, so first sun path has to be analyzed properly to understand from which direction sun is coming and how it can be blocked. Without knowing sun path diagram, whatever the shading design you are doing might be over engineering or under engineering also, because you won't know exactly where to stop your shading. You will be giving 10 meter of shading, whereas it just needs 5 meters or 5.8 meters, something like that. So, understanding sun path diagram is also very important aspect of shading and shading design. So, this is an example of tinted glass which is being treated with a coating which reduces and reflects radiation, and this is different sun location according to different dates. So, as you see, the December winter sun is usually low lying, and as we go from March to June, the sun level increases, and during June or summer months is usually very high, and the solar radiation is also a lot. For example, building orientation, overhang and other features can be designed to capture sun's heat in cold climate and avoid it in the hot ones. So, it is not just for one climate, you can make your design to change according to your seasonal variations also. Say for example, in locations like Europe countries like Greece or Spain, the summer temperature goes up to 40 degrees Celsius, but whereas the winter temperature goes even to minus 3-4 degrees Celsius. So, they need to come up with different strategies which will work better for during winter months to gain passive solar heating, and also during summer months when it will neglect solar radiation completely. So, as you see, this is the winter aspect and summer aspect. So, here in this picture, if you observe, the sun's location is different in two different images, because this is a winter month, so sun path is very low, and when it is a summer month, sun path is higher. So, the sunshade is designed according, it will block only the summer radiation and it will let in the winter radiation. So, passive cooling. So, moving on to passive cooling is the least expensive way to cool your home. To be effective, passive cooling technique need to cool both the house and the people in it. With elements such as air movement, evaporative cooling and thermal mass, passive cooling design technique can be applied in new home as well as renovation across a range of different climatic zone. So, passive cooling is similar to passive heating. This is passive cooling is just focusing on cooling and cooling effects which can be adopted for in climatic zones such as tropical or warm and humid and hot and dry climates. This type of techniques can be used to reduce the air conditioning bills, in which it takes advantage of ventilation and windrows pattern and prevailing wind directions, etc., and eliminating the solar radiation by knowing the sun path diagram as well. So these are different type of passive cooling techniques which will be dealt later. The sun heats building, especially on dark roof and pavement. So when you want to adapt to passive cooling, your building will be located on tropical region or wherever the sun is very high. So when the sun is very high, the incident solar radiation that's falling on a horizontal surface such as roof is very high. So you need to consider the roof material should not be in darker color, and it's more encouraged to use reflective surfaces to reflect back the incident solar radiation. You can minimize unwanted heat gain by choosing more reflective surface or vegetation. So as you see in this picture, it's for passive cooling. So different surfaces, as we know, this horizontal surface is going to absorb lot of solar radiation. So here you have to avoid dark roofs like this, and you have to use more of reflective roofs or vegetation. Passive solar heating. Passive solar heating is the least expensive way to heat your home. Put simply, design your passive solar heating keeps out summer sun and lets in winter sun, while ensuring that the building envelope keeps the heat inside in winter and allows any built up heat to escape in summer. Orientation, thermal mass, ceiling and other elements all contribute to the design of a house that benefits from passive solar heating. So, passive solar heating, as we saw in passive cooling, this is how to heat your home when you are building a home in a much colder region or a prolonged winter months. So, if you are in a composite climate, say for example, if you are in a place in which even the winters are very harsh and even the summers are very harsh, a passive design must ensure letting in the winter sun, and it is making sure even the external heat which is being built up during the summer is having proper provisions for the heat to escape. So as you see, so the shading and the window location is being made according to the winter sun. So the winter sun can get in, but the eaves are being projected out in such a way it's blocking the summer sun to control. So you have to provide controls on this window, and it should not be made as a completely fixed glass, because when the summer heat is being built within the space, you need some ventilation or opening for the heat to release or escape outside. Only then you will feel equivalent to outdoor temperature, or else your home might be even very much differential temperature towards the outer and the inside temperatures. Different material like thermal mass and distribution patterns of internal gain and observers can be used, which will be discussed in detail in the next unit. Energy also radiates in and out of building through windows. So you can make windows work for you by optimizing the window to wall ratio on each side of the building and choosing windows that optimize how much energy passes through as infrared visible light and higher frequency radiation. So when you are designing windows, you should consider wall to window ratio. Say for example, if you are designing for passive solar heating, your window, having lot of window must be very good if it is letting good solar radiation, but on a disadvantage to the same point, it can also have lot of air leakage, which is making the cool air from the outside, which is penetrating through the air gaps and it's coming inside. So we have to come up with an optimum balance to maintain the thermal to log the thermal comfort within the built environment, and not to and also to invite the solar radiation from outside, but to reduce the heat loss or heat loss and energy efficiency. Thermal mass. Thermal mass is the ability of a material to absorb and store heat energy. A lot of heat energy is needed to change the temperature of high density materials such as concrete, bricks and tiles. These materials have high heat storage capacity and therefore said to have high thermal mass. Lightweight materials such as timber have low thermal mass. So this is why when you are looking at buildings for colder climates, thermal mass becomes very crucial, because thermal mass are the materials which will have high heat storage capacity. So what is heat storage capacity is when there is heat which is being produced within a space, the capacity of the material must be high to trap and absorb and protect this heat within, and it should not be light or low heat capacity. If it is a low heat capacity material, then it will automatically, whatever the heat is being coming and falling on the material, it will automatically get transferred to the outside. So as you see how thermal mass works is, in this picture, daytime when the winter sun is low, it falls on different surfaces and all the surfaces is made of thermal mass. This thermal mass makes sure this incident solar radiation will be observed on all these different surfaces. When there is during the evening or night time, when you are using heating, you are going to close your window completely and protect your window. So the whatever heat that is being observed during the daytime will be emitted out, and it will make sure the built environment is kept in a comfortable temperature, and it reduces the usage of room heaters. Use of materials with high thermal mass throughout your home can save significantly on heating and cooling bills, but thermal mass must be used appropriately. Poor use can accelerate the worst extremes of climate, radiating heat on a hot summer night and absorbing all the heat you produce on winter night. Good use of thermal mass moderates indoor temperature by averaging day-night temperature extremes. So choosing what type of thermal mass and heat storage capacity is very crucial, and it depends on location to location. So as you see in this picture, this graph shows this yellow is the outdoor temperature, which is very high. When you are using light timber framed building, the indoor temperature is shown by light green. But when you are using heavy building with external insulation, which will be good thermal mass, the temperature is this how the temperature will follow. So as we can observe, there is the peak of temperature is reduced, and even the colder temperature are maintained, because the heat that is trapped in during the day will get emitted during the night. And these are different examples of thermal mass. Glazing. Glazed window on door brings in light and fresh air and offer views that connect interior spaces with the outdoor. However, they can be major source of unwanted heat gain in summer and heat loss in winter. So next, learning outcomes. So let's see what we have learned in this whole video. So first we started with introduction to passive design and its importance and its advantages, and then we moved on to simple passive design consideration for a better design, and then brief discussion about passive cooling and heating and various strategies and how to achieve them, and then we studied about thermal mass and insulation and its importance. Questions: what is passive design? What are the advantages of passive design? How is orientation essential for passive design? And explain in detail about passive heating and cooling. How thermal mass can make your home better. What is insulation, and state some of its uses and climatic application with the same. Thank you.